Welcome to my presentation on the topic of the evolution of bipedalism. My name is Celeste Close and I posed the following question to myself after reading a paper by Madalena Burma from 2019. The question is, what implications does the recent discovery of Danuvius guggenmosi have on the story of human bipedalism? Modern humans are the only extant species on the planet that displays obligate bipedalism. During the 1900s, this trait became an identifying feature of the hominin genus and was used as an anthropocentric tool to define humans as unique from other species. Multiple hypotheses exist to explain the emergence of bipedalism. The most common examples are for freeing up hands to carry and use tools and weapons, for seeing long distances, for making threat displays and fighting, for providing and protecting a mate, for transitioning from arboreal habitat to savanna, for gathering and reaching for food in trees, and also for cooling the body more efficiently. It is unlikely that bipedalism emerged because of only one of these factors, and more likely to have been a combination of factors. These hypotheses still do not answer the questions when, where, and from which mode of locomotion did hominins evolve. Two competing hypotheses have emerged over the last 100 years regarding the most likely mode of locomotion that preceded hominid bipedalism. The first hypothesis is the terrestrial bipedal hypothesis, which has been the prevailing hypothesis since the 1960s and posits that habitual bipedal locomotion in hominins emerged from a terrestrial knuckle-walking quadruped similar to a chimpanzee or troglodyte. Research supporting this hypothesis has been based on behavioural observations and comparative anatomy, particularly in the wrist joints of African apes, humans, and fossils of the African genus Australopithecus. Thanks to this illustration published in 1965, the incorrect notion that man evolved in a linear progression from a knuckle walker to a biped has been pervasive in popular culture. The second hypothesis is the arboreal bipedal hypothesis, which has come in and out of popularity since the early 1900s and posits that habitual bipedal locomotion in hominins emerged from an arboreal brachiator quadruped, similar to a gibbon or hylobate. Research supporting this hypothesis has been based on recent findings, comparative anatomy, biomechanics, and wrist morphology in living apes and monkeys. Recent discoveries from the last 10 years challenges many traditional views that habitual bipedal locomotion in hominins evolved on the ground in Africa. Research supporting this hypothesis has been based on recent fossil discoveries, phylogenetics, and comparative anatomy in living monkeys and hominid fossils. The commonly held concept that terrestrial bipedalism defines the separation between hominins and panins less than 8 million years ago, has increasingly been challenged over the last 2 decades. It was thought that because our closest relatives, the chimpanzees and gorillas, were quadrupedal knuckle walkers with a pronograde posture, then hominin pre-bipedal ancestors must have also evolved through this phase. New fossil discoveries are showing that bipedalism and other ape features evolved in an arboreal context. The ancestral hominoid, which is the ancestor to hylobates, Miocene apes, and great apes, possessed an orthograde posture, extended lower limbs, and was able to travel bipedally along branches with hand-assisted stabilization, a trait which all apes are capable of engaging in. Orangutans and hominins show similarly adapted extended leg morphology. Considering that modern orangutans are completely arboreal and modern humans are completely terrestrial, but share a common bipedal function, suggests that bipedalism evolved in the trees. Madalena Burma and her team has recently discovered and described the remains of 4 individual hominid fossils in the sediments of Hammerschmiede clay pit in Bavaria, Germany. Danuvius guggenmosi has been classified into the extinct tribe of Dryopithecini based on its craniodental similarities to other Dryopithecine apes. Magnetostratigraphic analysis has dated the find to have been living 11.6 million years ago in a woodland habitat. The body mass calculations estimate the new species to be smaller than a bonobo, with males weighing an estimated 31 kilograms and females a smaller 18 kilograms. Exceptional preservation of the limb bones has provided evidence of a new type of arboreal locomotion called extended limb clambering. The key characteristics of an extended limb clamberer is the equal use of both forelimbs and hind limbs and the combination of bipedal and suspensory behaviours. The upper body is adapted to brachiation and suspension with powerful pollicle grasping, curved phalanges, mobile wrists and flexible elbows. The lower body is adapted to orthograde posture and bipedalism with powerful helical grasping, plantigrade feet, weight-bearing ankles and knees, extended knees and hip, elongated lumbar, and spinal lordosis or curvature. In addition to the increasing library of fossil discoveries from Africa and Eurasia, advancements in molecular DNA analysis and other technologies, the discovery of Danuvius guggenmosi creates exciting implications for the story of human bipedalism and evolution. The fossil find potentially extends the age of bipedal origin from 4.4 million years ago to 11.6 million years ago, and relocates the origin of human evolution from Africa to Europe. It also potentially rearranges the bipedal ancestry in the phylogenetic tree. Humans' bipedal ancestor was thought to have been a hominin, and the pre-bipedal ancestor was thought to have been a hominid, being the last common ancestor of tribes Hominini and Panini. It is possible the pre-bipedal ancestor could now potentially be a hominoid, being the last common ancestor of families Hylobatidae and Hominidae and other extinct apes with extinct modes of locomotion. Significantly, the discovery of Danuvius guggenmosi suggests an arboreal origin for both human and ape locomotion, suggesting that humans are not as unique as they once thought. Thank you for listening to my presentation, and these are my references.